All right, so in this video, we're going to look at some additional pandas functions, importing data from an Excel sheet that has multiple sheets. We're also going to look at looking at importing from CSV files, and then we're going to be working with some graphs. All right, so as with the previous video, we're going to import pandas to get started. Generally, it's always a good idea to import any packages before you try to use them. Now notice that we're importing the pandas package. When we want to call functions from pandas, we don't necessarily always want to retype pandas. And so in order to save ourselves a little bit of typing, we import it as a particular abbreviation. PD is very common for pandas. And so when I want to call functions from that pandas package, I don't have to type pandas out every time. I can just type PD. Now, for this particular example, I want to import a data set from Excel that has actually 3 sheets to it. The first sheet has really no information on it except source information, where the data came from. And then there are 2 additional sheets that have data on MBA programs in, graduate MBA programs and undergraduate business programs to compare. Now, if I just use my read Excel function that I used in the last video for this particular purpose, then I'm not going to be able to get any information out of it, because with multiple sheets, this read Excel function is only going to import the first sheet. And the first sheet of this data, of this Excel file, actually doesn't have any meaningful information on it. But we'll run it and we'll see what happens. So if I run this, again, same function I used last time to import my employees data file, and then I look at the head, nothing happens. So no data was imported because there is nothing on that first sheet of this Excel file except a comment. Now, if I have multiple sheets, then I actually need to use a slightly different function. It's also in pandas, and it's called Excel file. It has these capital letters. So it's a little different than the one that we were looking at before. And what this is essentially going to do is it's going to import the Excel file in a slightly more true format. And then we're going to use this parse function in order to pull out the individual sheets. Now, you will need to know what the names of the sheets are that you want to extract. And you'll just simply put those names in quotation marks. They can be single or double quotes in Python. Python is a little bit more flexible about the quotation marks. But here I've used single quotes. And we're going to, again, import the file and then extract the first of the 2 sheets that have actual content on them. So once I use this parse function, I've saved it as a data frame, and then I can look at the data frame. So this is the data that comes in from that data frame. Again, it's quite long, so there's a scroll bar here. There's quite a lot of information in here. And then if I want to import the other one, the undergraduate data, then I use basically that same parse function, but I just have to change the name of the data frame I'm saving it to. So here I'm saving it to undergraduate data, and I'm parsing out just the undergraduate sheet. And so now this is my resulting data frames. So now I have 2 data frames from each of the different sheets, and then now I can proceed and do my analysis as before. But again, if you use the original read Excel, it will only import the top sheet. If you have a sheet with multiple pages on it, but you only want the top sheet, you can just use this standard import function and it will work just fine. But if you need the second sheet or multiple sheets, then you need to use this alternate function and then parse out the different sheets by name. All right, so sometimes we may need also to import functions, import information from other kinds of files. So a very common kind of file is a CSV file. This particular CSV file I actually downloaded from the New Zealand data services, their national statistics function, essentially similar to their Census Bureau or their Bureau of Labor Statistics kind of thing. And the data comes out as a CSV file, which is a comma separated values file. You can open these in Excel very easily, but they're basically text files that have commas between the entries. And there is a read CSV file function in pandas, like the read Excel file that we were using earlier. And it basically works the same way. It just matches the file type and it imports the information into a data frame the same way that the Excel file did. So often when you're at various websites, you will get data in different formats, and we will look at other kinds besides these as we go through the tutorials. But these are the two most common: Excel, particularly if you're in a business context, or you will see CSV files regularly as things that you can acquire off the internet in terms of data files. Now, to continue with our analysis, we're going to re-import the employee data that we were looking at in the previous video. So again, I'm using the read Excel file because I know this one has only one sheet of data. And then, of course, we'll look at it. Oops. We'll just look at it as the first 5 lines to remind ourselves what's in there. Now, for the next thing that I want to do, I want to actually summarize our data by grouping it, so aggregating it, grouping it into different, looking at all the education or looking at how men and women differ. So we're going to do this grouping function. And what we're going to do is then calculate by both sex and education the age of each of the groups. So I'm going to specify in this case a list of the groups that I want to group it by. So here I'm specifying gender and education. You could, instead of using this variable and assigning it first and then using our groups variable in this function, you could just use this list directly inside of this function right here for the group by function. It may be easier to specify it separately and then makes it easier to change as you go. Now, I've used gender and education here because they are essentially the categorical variables. If we look back at our data set, there's actually a discrete number of values. There's only, if you go through more of the data, 0, 2, 4, 6, and 8 available for education. And gender, of course, has only 0 and 1. When you're using the group by function, you generally want to stick with discrete or categorical data that doesn't have a lot of values. The more values you have, the crazier this table is going to look. And it's not really designed to be used with continuous data, which has lots of different values. So we're going to group the data by gender and education. Again, using this group by property, we're going to use this as index property set to false. And then we're going to calculate the mean of each one of these groups. And then finally, we're going to display the result that we've saved to a file, to another it's a variable, essentially, a data frame of some sort. We're going to save that, and then we're going to round it when we display it to just 2 decimal places. So we talked about the rounding operation in the previous video. This is the same function. It's just that the thing we're rounding now is we're going to round all of the values in the entire table, not just a single value. So if I run this, I get a list like this. It's a data frame. Gender, all grouped together 0, all grouped together as 1. And then education is listed consecutively, 0, 2, 4, 6, 8, and then 0, 2, 4, 6, 8. And then we have the average age rounded to 2 decimal places for each of the categories, each of the averages. So we can see that the people with no education, the men have an average age of 33.5, whereas those with a doctorate degree have an average age of 45.5, so obviously they're older. Interesting that associates and bachelor's degrees both have exactly the same average. And then among the women in our data set, the youngest group is the one with the least education. What's interesting here is that the PhDs in our group actually are younger than those with the master's degrees or with the bachelor's degrees, or for that matter, with our associate's degrees. So that's a little odd, but that's interesting. So this is the way that the grouping function works. It will group all the zeros together, and then if you have all the categories of gender together, and then within that, it will further subset the group by whatever second category. So if you had only one category, gender and age, you would just see 2 rows of the data and the average age of gender and the average age for men and for women. But because we've done it by gender and education, so it does the gender first, and then within the gender, it does all the education levels. And then likewise, within the second gender, it does all of those individual education levels. And once it's in this data frame, then you can do all of the other operations on it that we were working on before. Now, we can also use the summarized data to create graphs, and we may do that in future examples. Now, in order to create graphs, I'm going to use, so matplotlib is one of the most commonly used packages for graphing in Python. I find personally that you have to do a lot of specialization, a lot of customization if you want the graphs to look nice. So it has it's one of those things where if you want to do a lot of customization, you can, which is great. But sometimes I just want nice graphs without doing that much work. And so we're actually going to build most of these graphs using a package called seaborn, which we are importing as SNS, so that, again, we don't have to type out the whole name of it every time we use it. Similarly, for matplotlib, we're going to import as PLT, short for pyplot. Now, seaborn is built on matplotlib, pyplot, so we will use them kind of in combination. But the nice thing about seaborn is that it collects a lot of things together so that you don't have to apply a lot of customization in order to get the graphs to look nice the first time. And then you can use the matplotlib functions to further modify, further enhance the graph once you're happy with it. All right, so since we group the data by categorical variables, we're going to use a bar graph to display the results. And so we can make a bar graph that displays, for instance, in this case, how many people are in each gender. So the function that we're going to use is called a bar plot because it's making a bar graph. And X is the gender. So again, males and females, 0, 1 gender. And then Y is the age. Now, age is a continuous variable. And so when you're using a continuous variable like this as a bar graph, what seaborn is going to do is it's going to calculate the average age in that group. And again, this is actually somewhat similar to the way R works in terms of the syntax, and we're going to refer just to the column names by the column numbers. So X is gender, Y is age, and then elsewhere specify that the data frame that I'm drawing information from was my employee's data frame. And then the plt.show is just going to display the graph once it's been constructed. So if I run this, I forgot to actually import my packages. I talked about them, but I didn't import them, so I got an error. Going back, let's run this again. There we go. See, that's what happens when you're talking. So what happens with this graph is you get this graph. It has gender here, 0, 1. It's got age here. And then what it's done is it's calculated the average age of the men and the average age of the women. And then it's also calculated an error bar for us at the top of this graph. Since we're calculating an average age based on a sample, presumably, of our data set, then it's going to treat this like a confidence interval. And it's going to tell us that if this was in fact a sample, there is a little bit of wiggle room in terms of whether, for instance, the female average is within the average bound of the men. And so we can't really tell from this data whether women are if this was a sample, whether women are actually older than men or not, because the difference between the two ages is not outside the range of these error bars. Now, you can't see the whole thing on the screen at once because I have this blown up so that the text is easier to read. But that is a nice graph. And then we could use, as we'll see later, I'll give some examples of how to tweak some of these properties using the pairplot functions, the matplotlib functions. Now, if I want to just do a count of the number of employees, that won't, in the data set, that won't be an average calculation. And so the error bars won't appear on the bar. And I also won't need a separate y variable because it's just going to count them. And we're not going to use the bar plot function. We're going to use the count plot function. And so if I run this, so again, you can see that there's no error bars on here because counts are not things that have errors. They're not averages. And it's, again, 0 and 1 on gender. Count is marked on the horizontal axis. And in this example, this data set appears to have more women in the data than there are men, which is interesting. Now, as I said, we can also use matplotlib to modify the look of our graph, so we don't have to only use the defaults. So these are some examples of things that we can do to modify our graphs. So here I'm going to change the style of the graph from the default to a style called white grid. You can look into the seaborn documentation to see what are the options that you have for these defaults. I believe there's dark grid and some other kinds of options as well, but we're going to look at white grid for this example. We're going to rebuild our count plot that we were just looking at before. We're going to add a title to it using the pairplot function. So we're going to put a title at the top that just says count of gender. And then we're also going to use a function called dspline, which is going to take some of these lines off of our graph on the outside. And then we're going to show the resulting graph. So notice what happened here. All these exterior boxes were removed. We have a title at the top, count of gender, and the white grid has added grid lines in the background with a white background. Now, I will mention that once you change this set style to white grid, all of your future graphs will have that until you change it back, which is fine for example purposes. Now, if I want to compare two numerical variables to each other, I can also use a scatter plot. So in this example, I'm going to plot age versus annual salary, and then I'm going to set the color of the dots on my graph to be red. And again, you can see we're using the white grid function in the background here, and all of the dots are red. We've got age on the horizontal axis and salary on the vertical axis. Now, one thing to note, I use the pairplot scatter function here, not the seaborn scatter function. So you'll notice some of the differences. There's no axis titles here telling me what the variables stand for. that did show up automatically when we use the seaborn package. And so this is one of the downsides of using the pairplot just by itself, is that you will have to specify all of those extra things like axis titles and even just the basic axis titles. You can change this color here to anything you want. There are a bunch of built-in sort of common colors that you can use just as names. Some packages will prefer other things like hex codes, but you can use other things here like orange or blue or green or what have you. And again, there's a wide variety of them. And check the default documentation for the matplotlib pairplot function to get a list of the different colors names that you can use. But obviously all the standard primary colors are in there. Now, I can also color code the graph by one of the other variables in my data set. So if I plot this by age and annual salary, I could color it by, let's say, the gender variable. Now, the default here for the gender variable, this pale beige color, is not very attractive. So this is something that you would want to adjust if you were going to try to use this. If you had a dark background, this might not be too bad, although then the black might be difficult to see. We could also change this from gender to education. And then we would have 5 levels of education, and they would be on a scale from pale to dark would be the PhDs, presumably, or again, vice versa. Now, you would want, when you had something like this, you would want to add a legend. And so there are ways of doing that. I'm not going to run the cell. I've just included these here as sort of examples. If I want to add an X label, I would have this X label function, and then I would name the variable. So again, in pairplot, in matplotlib proper, and not seaborn, you have to specify this. In seaborn, they will take it out of the column names for you. You can also adjust the range of the plot. So if you want to see more or less of the data, you can adjust the ranges of X and Y by setting these limits. Again, these are just examples. They would not be appropriate for this particular graph. We've looked at the title, adding a title. You would put your name of the graph in the text string here, and then again, run that before you do PLT show. So create your graph and then add these as properties after that. And then also a legend. You can specify the location, lower center, top center, lower left, so forth. And then once you've created your graph, you can also save the graph into a file if you want to use it in another application. So plt.save figure, and then name it something. And this will save whatever file, whatever your last graph was, it will save it as a file with this name. And you can use other extensions besides PNG. But give it a real name, not just name. Now, we did a scatter plot, but if I want to do a regression line for my data, I can show the regression line with the data, the scatter plot, or without it. So in the regplot function, which we're going to look at again in a future lecture, I'm going to plot age versus annual salary. If I want no scatter plot, I will set scatter equal none. So it will calculate the regression line and then plot the regression line, but not plot the scatter, the original data points. And here I've set the color to be blue. So this is my regression line. These are my error bars on my regression line. No scatter plot. And if I were to remove, for instance, the scatter equals none, then it would plot the regression line along with the original points. So you can use them or not use them as you see fit. You may want to focus more on the regression and less on the scatter points, or include them as context. Now I can also, with my lmplot function, I'm going to also plot age versus annual salary, but I am going to create two graphs, one for males and one for females. So I'm going to change the color of the graphs by using hue equals gender, but I'm also going to separate them into two different graphs by using row equals gender. So I'll have one graph for men, and then below that, I'll have a second graph for women. So let's look at that and run that. And so here's my top graph. It says gender equals 0 right there. And these are all the male salaries with my regression line plotted. So again, LM is just stands for linear model. And so it works similarly to the regplot, the regression plot we had earlier. And then the second one is gender equals 1. And so these are the female salaries with its own regression line plotted. And again, you can make adjustments to this. Again, feel free to play around with your own data. For instance, what happens if you remove row equals gender? They can be plotted on top of each other and so forth. You can also keep the color the same if you have row equals gender, but you remove hue equals gender. And then the last thing that I want to show you in this example is a pair plot. Now, a pair plot is a way of looking at all of the variables in your data set all at once, and in order to see combinations, essentially scatter plots of pairs of your variables against each other. This is a nice way of kind of doing an initial data inspection and just kind of see, is there any relationships between the variables that maybe you can exploit in models, just get an idea of the way that they behave. And so this seaborn pairplot function is really great for just sort of a preliminary glance at all of your data without having to literally go through and create all of these pairs yourself. And it does take a little bit of time to process. And I will say that the more variables you have, this can be quite difficult to read. But for 7 variables or something, this isn't too bad. I would also recommend that if you were actually doing this on a real data set, that this employee variable that we had way at the top, if you go back to our original, where is it? So our original employee data, that employee variable, it's not a real variable, as we mentioned in the last tutorial. This is essentially an index. And so ideally, before you create your pair plot, you should remove this column from the data. But for our purposes, we can just ignore it at the moment. You can see that it's not very interesting. It's uniformly distributed, boring. There's no relationship between that and any of the other variables. It's all pretty random. So again, this employee variable is not really a variable. It's not useful in any way. But we can see along the diagonal here, the pairplot function has created histograms of all of our data. So a bar graph if we have only discrete values, but we can see the shape of the distribution of each of our variables. We can see, like again, in this education category, we can see that the most number of people in the data set are bachelor's degrees, which I guess is not too surprising. Our annual salary histogram we'll look at how to make individual histograms in a future video. And you can see that, for instance, there is some relationship between age and salary, between prior experience and beta experience and salary, and also, not too surprisingly, education and salary. Some of these other variables don't look like they are all that related. So the gender, there's more higher people in the males, but the spread is very similar in both cases. Again, the employee number doesn't really mean anything. Some of these other variables don't seem to have a lot of relationships with them. So for instance, age and beta experience, they're kind of all over the place. But again, this last column is showing the same data as this last row, just on different axes. And so again, you can see that there's this relationship between the variables. So again, this pair plot idea is just a good way of getting a quick glance at all of the variables and seeing how any of them, if at all, relate to each other.